on This versus That.
What's better to barbecue with? It's propane versus natural gas. When it comes to barbecue, every true aficionado knows there's only one way to do it correctly. Giant slabs of meat cooked low and slow over an open flame. Flame that we get from burning wood.
Now, at its peak, wood can burn at 1,000 degrees Fahrenheit. Oh, pretty close, actually. Now, the great thing about cooking with wood is that you can actually control the heat. You can keep it low, 150 degrees. It's a smolder. It's nice for smoking meat.
Or 1,000 degrees, the flesh of the meat sears, locking in its juices and making it less likely that your steak will turn out all dry and nasty. All right, but not everyone barbecues with wood. Why? Well, first of all, it's expensive. You gotta buy it, then you have to split it, then you have to store it someplace. It takes up a lot of space, and then when you burn it, all the smoke goes up into the sky and it makes people like Ed Begley Jr. very, very angry.
Oh man, when he hulks out, it's like,
Forget about it. You don't want that,
yeah.
no.
So, if you are cooking meat outside on an open flame, you, my friend, have got a decision to make.
Here are the facts. 75% of Americans have a barbecue grill. Of that 75%, 35% use wood or charcoal to make fire.
Everybody else uses gas. Now, of that gas group, 65% use propane, 35% use natural gas.
Right. Now, when you're barbecuing, what is that?
That is me at a natural gas grill. There's a gas line from the house out to the gas
What are you
grill.
wearing?
I have a spatula and tongs because you just want to make sure that you're prepared to do your barbecue. We should get into that.
Please tell me that you use a spoon to serve the potato salad.
Oh, yeah.
What was that, you ask? Well, we're going to tell you. We've designed an experiment to figure out which gas burns hotter, propane or natural gas.
Because hotter is better. Just like the Kardashians.
Sure.
To determine the hotter gas, we're going to calculate each flame's adiabatic property. Since temperature is thermodynamically conjugate to entropy, the isothermal process is conjugate to the adiabatic process for reversible transformations. I'm kidding. We're gonna blow up cans of baked beans. Yeah!
Inside the can, not only are beans, but there's also a lot of water in here. And as water gets hotter, what happens?
Turns to steam, Mark.
It sure does, Chris. Steam creates pressure inside this sealed can. At some point, the pressure will be larger than the can's ability to hold it. And then you know what you got. Huge explosion.
Bang.
Beans everywhere.
The money shot.
That's what we call it. So, here's our test. We're gonna see how long it takes the propane to make the beans go boom. Then we'll do the exact same test with the natural gas. Whatever can blows up faster had the hotter heat source.
Absolutely. Science, here we go.
Why do you have a fork?
Well, there's gonna be hot beans at the end of the experiment, so we're gonna num, 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 num.
They're gonna be everywhere though, Chris. They're
Yes.
not gonna be in a nice little bowl. They're gonna be on this plexiglass.
Eat it up.
It's gonna be on the razor wire.
Eat
It's
it
gonna
up.
be on this guy over here.
Eat it up twice.
Now it's time to get started, so I thought we would bring in a actual chemist to help us with this next part. This is Dr. Alf. Welcome to the show.
Nice to meet you.
Hi, doctor.
Now you are from UCLA and you're a chemistry professor?
I teach organic chemistry labs there for about 10 years now.
Professor Bacher has a doctorate in chemistry and teaches organic and advanced inorganic chemistry and chemical instrumentation. However, he's mostly here to make sure we don't blow up ourselves or this box of abandoned puppies we found. Oh, puppies, so sweet. Plus, he can explain the molecular differences between propane and natural gas.
The methane, which is the main component of natural gas, has one carbon and 4 hydrogen atoms.
So, during combustion of natural gas, 1 molecule of carbon dioxide and 2 water molecules are formed.
The propane has 3 carbon atoms and 8 hydrogen atoms.
Whereas when propane combusts, 3 molecules of carbon dioxide and 4 molecules of water are formed. You see, there's a relationship between how much water and carbon dioxide each gas creates when it burns and how much heat each gas generates when it burns. It's the mystery at the heart of this experiment.
So let's start with
the propane.
propane. Tell us about
The
propane.
advantage of propane is it has a very good heating value. The temperature is pretty high, so you can sear your meat very nicely.
It burns nice and hot.
And it has a relatively clean combustion.
Perhaps propane's biggest disadvantage is its weight. At 1.5 times the weight of air, if your propane tank has a leak, the gas will sink and pool on the floor rather than dissipate, making it susceptible to combustion by any careless cigarette smoking dolt.
That's enough science.
Let's blow some crap up.
Yeah, all right.
We want to blow up the bean can. What do you expect we're going to see? Beans and death?
No,
Are we in danger?
I don't think we're going to be in danger. We have protective walls, obviously.
Yeah, look at that.
We're going to wear some hard hats and all the other safety equipment, so I don't think we're going to be in danger.
Is it going to blow up like a bean grenade? Is it going to blow up in the air? What should we expect?
Sometimes they just release the steam somewhere on the seam of the can. Sometimes, if it's really well sealed, manufactured, the bean can might get airborne.
How high? How high can we expect?
Maybe about 100 feet.
Oh, that's good.
100 feet of beans? Let's do it.
Let's release some gas.
Coming up, a symphony of percussive legumes. And we've got it covered with 5 different camera angles. And here's an outtake from earlier we didn't have time for until now.
Is that the new iPhone?
No, actually, this is a thermal imaging camera. What you do is you point it at whatever you want to get the temperature for. Red, for example, the fire right now, very hot. Meat, blue, cold. Your face, red. Your junk, blue. Blue, blue, blue. It's where Smurfs go to die in an icy tundra. Just abandoned.
Get it.
What's wrong? I was using science.